We can look back at our notes, right, from a couple days ago. A method for solving a system of equations. Oh my gosh, Noah. He's literally still wandering around the house. Oh. That is not it. All right. A method of solving for solving a system of equations. By adding or subtracting. To eliminate a variable. So remember, we have to add or subtract the equations to eliminate the variable with common coefficients. Step 3 is to solve for the remaining variable. And then once we know what one variable is, we're going to substitute that answer into either original equation and solve for the other variable. Okay, so we dealt with this problem yesterday. What if there are no common coefficients? We have to multiply one or both equations by some number we're going to multiply one or both equations by some number, bless you, to create matching opposite coefficients. So if they're already matching an opposite, we can go ahead and add. If they're already matching but not opposite, remember that's when we distributed a negative through to subtract. Sometimes they're not matching or opposite. So we might have to multiply one or both by something. So what could I distribute through this top equation to make a -2? So it's the opposite of the x coefficient. What times x is -2x? This shouldn't be a difficult question, right? -2. So if I distribute a -2 through here, I have -2x minus 6y equals negative 12. So then I would rewrite the bottom one here. 2x minus 7y equals negative 1. This is what we want to happen. We have matching opposite coefficients, so they cancel each other out. Here I'd have negative 13y is equal to negative 13. So y has to be equal to 1. If I look back at this original first equation, I have x plus 3 times the y value, which is 1, is equal to 6. So simplified, this is really just x plus 3 equals 6. We can solve that one step, right? So I would subtract 3 from both sides. X is equal to 3. All right, so we're just reviewing what we learned yesterday. Now, I would have to multiply both the 9 and 2 by something to get them to match. So if I look at my y, what could I just multiply through the bottom to get it to be the opposite of 3? Negative 3, right? So I'm going to rewrite my top first. 9x plus 3y equals 12. And then I'm going to distribute that negative 3 through here. So this becomes negative 6x. That bracket makes it look like a 12 kind of, sorry. And then negative 3y. And then negative 15 is what it equals. So now I can add these up. 9 minus 6 is 3x. My y variable goes away, and this is negative 3. So if I divide both sides by 3, x is simply equal to negative 1. If I look at my bottom equation, remember you can choose either. I'm going to put this in for x because it's what x equals. So 2 times negative 1 plus y equals 5. I try and pick the one that has the other variable by itself, but sometimes you don't have that option, and that's okay. So here we have a negative 2 plus y equals 5. So if I were getting rid of that negative 2, I would just add it to both sides. Add 2, that is. So y is equal to 7. Oh, I didn't even give the final answer up here either. So this is 3, 1. This one down here is negative 1, 7. Silly me. All right, which looks like it would be easiest to match up for number 3? The x's or the y's? Always easy to just multiply by 1, right? So what would I multiply that negative 1 by to get negative 4? Just 4. So I'd have 12x minus 4y equals, oh no, 56. A cause for slight panic there for a moment. And then I'm going to rewrite the bottom. I'm not distributing anything through because I will already have matching opposite coefficients of my y. So when I add these up, 17x is equal to 68. I'm going to guess that's 4 times because 4 times 7 is 28. But you can definitely throw that into your calculator too. X equals 4. So pick either equation. I don't think either are easier than the other in this case because we have a negative y equals 14. So 12 minus y equals 14. I first have to get rid of the 12 by subtracting it from both sides. Then I have, careful with your signs here, negative y equals 2. So positive y has to equal negative 2. So this is the point for negative 2. All right, so we have a few more examples today. I could multiply this top one through by -5 to get this to match here, but I think it might be easier just to match our y's. So I might distribute what through the top to match my y's. A 2. So here I have 2x plus 2y equals -6. So the most important thing to remember when you're distributing, you're multiplying by every single thing in that equation. And then I'm going to rewrite my bottom equation, 5x minus 2y. That way things are nice and aligned here. So I have 7x. My y term goes goodbye. And this is -56. So when I divide both sides by 7, x is equal to -8. So I would definitely choose to throw that into the top original, -8 plus y equals -3. I would simply be adding 8 to both sides so that y is equal to 5. So this is -8, 5. All right, down here, I would probably opt to multiply by a -3. Why do I have to multiply by a -3? Because I want it to be the opposite of this one. I want it to be a positive 3y. So if I rewrite the top, 3x minus 3y equals -3, and then distribute that bottom, -6x plus 3y is what we wanted, is equal to a positive 15. Then I can add those babies up. So this becomes -3x. My y's go away. This is 12. When I divide both sides by the coefficient of x, x is equal to -4. So I might just pick the bottom one, I don't know. 2 times -4, right? Because that's what x equals. I'm plugging it in for the x value. Minus y is equal to -5. So -8 minus y equals -5. So when I add 8, I still have a -y on the left. Oh, I should have showed that I was adding 8, sorry. And then that becomes 3. So the opposite of both of those would make y equal to -3. So this would be the point -4, -3. All right, I would have to multiply both of these to get them to match, but this one I can multiply the top by something to get it to be the opposite of 8. What can I multiply by 4 to get -8? -2, right? So I'd have -6x, -8y is equal to -12. And then when I copy down the bottom, my y terms match up and are opposite, so they get eliminated. This is an x, ooh, that's nice, is equal to -2. We look at either one of these. If we see the top one, 3 times that -2 plus 4y is equal to 6. This gives us -6 plus 4y equals 6. So I'm solving that 2-step. getting rid of the constant. Getting rid of the coefficient by dividing it 3. So this is the point -2, 3. All right. So today your work is going to be done on pages 20 and 21. We'll start there and then I will throw in the pixel art for you to check your work for. These looks like will all require you to distribute something through. Trying to see if there's any nice ones. There's not, sorry. You've got to distribute something through every one of these. So I could get my x's to match up here, or I could get my y's to match up here. Which do you want to do? We can multiply this whole thing by 2 to get it to be 10x, or we can multiply this whole thing by 5 to get this to be 10y. You want to go by 2? So if I multiply a 2 through here, I have 10x plus 4y is equal to -22. And then I would recopy down that bottom. So these all come out pretty nicely. This becomes, as I say that, I'm looking at it now and I'm like, what? This becomes -6y. And this is equal to, oh, look what I did. I didn't multiply this by 2, so this should be 44. So -44 plus 20 is -24 there. Okay. No. All right, so I would just divide both sides by -6 here, so y equals 4. And then I've got to put it back into one of these to solve for x. So if I said 5x plus 2 times 4 equals -22, I would have 5x plus 8 equals -22. Subtract 8 from both sides. So 5x equals 30. When I divide both sides by 5, x is equal to 6. So these are all going to be put in the format in your pixel art with the x value and then the y value in parentheses with no spaces. All right, so keep chugging along. Remember you want equal and opposite. So if I was gonna make this equal, I would multiply it by 2, but since I want it to be negative, I would multiply it by -2. So think through those. I'll throw this video and that pixel art in Google Classroom so you can start checking your work as you're getting them done. About 12 problems, I think. So it's actually through page 22. We can go through a few more if you guys want to and you're done, or do you want me to keep going through now, or you okay? Or you want to do a few more? You okay? All right.